Investigate the unknown. Explore the unreachable. Discover the unidentified. On your mark, welcome to science class. We have been under quarantine since March, making us feel like a great summer vacation has been snatched away from us. What do you like to do in summer? Personally, I really like swimming. Nothing beats a brisk swim in the pool or the beach on a hot summer day. It feels good to float luxuriously on your back over the surface of the water. But have you ever wondered why we float? Today, join me and let us discover how materials float or sink. Notice these three basins with water. Let's call them Basin A, Basin B, and Basin C. We're going to drop some oil in Basin A, while we'll be dropping a rock in Basin B. In Basin C, we'll be dropping in an ice cube. From these three, what material do you think will float, sink, or partially float? Can you guess? In this illustration, the oil will float, the rock will sink, and the ice will partially float. Do you know why? The reason is that all materials have their unique characteristics, but in this situation, they differ because of their density. Density is the amount of matter per occupied space. It can be imagined as the amount of particles that are compressed in a certain amount of space. Simply, density is mass divided by volume. You can compute the density of a certain material based on this formula. Let us imagine this situation. There are two boxes that contain different materials. Box A has 1 kilogram of marbles, while box B has 1 kilogram of feathers. They both weigh 1 kilogram. But if I throw these boxes in the river, which one do you think will float? Of course, it's box B. But why? It's because this box is less dense than water. The ability of a material to float or sink in water is dependent on the density of the material. Water's density is 1 gram per ml. And if the material is less dense than water, it will float. But if it is denser than water, it will sink. How about the ice? When we dropped the ice into Basin C earlier, the ice did not completely float or sink. Instead, it was suspended in the middle. This is because the water's and the ice's density differ a little. This same reason goes well with other materials that partially float on water. Aside from density, water absorption affects the tendency of the material to float or sink. Porous materials, just like our previous lessons, these are the materials that contain pores. These materials are light and they will surely float. But when water gradually enters their pores, they will sink. Non-porous materials. Some of these kinds of materials initially float on water. But if you put holes in the body of a non-porous material, that will allow the water to flow through that hole and it will surely sink in due time. Most non-porous materials directly sink in water. Lastly, the shape of the materials also matter. For example, a piece of molten clay. A flattened piece of clay will float, while a compressed clay will sink. Indeed, the shape of the objects sometimes affect the material's capacity to float or sink. In a deeper scientific sense, floating or sinking involves a lot of force. But as for now, it is clear to us that materials will float or sink in water depending on their density. I hope you will remember what we discussed today. Goodbye for now. See you again next time. This has been Teacher Runir for ClickGen.